In our previous video, we found the location of the minimum of the stationary point and the nature of it, and we found that it was a minimum point, and it's for this equation y equal x squared minus 2x minus 3. And we sketched the curve, and we found that we got the same thing when we plotted the curve using GeoGebra here. Now, what we did to find the nature of the minimum point was to find out what the value of y is to the left of the stationary point and to the right, and we saw that both of them were higher, so it must be minimum. Let's look at another way to find the nature of this minimum point. The thing is, if we look to the left again of 1 and we look at negative, no, not negative, it's positive, but we see it is to the left of 1 and it's 0.9, and then to the right of 1 and we use 1.1. all right, now at 1, dy by dx is 2 times 1 minus 2, which is 0, which we knew already because we equated this to 0, and that's how we found that the stationary point was located at x equal 1. So if we substitute 1 here, we get dy by dx equals 0 at the stationary point. Now, at 1, dy by dx equals 0. Question is, what happens at 0.9 and what happened to dy by dx at 1.1? We want dy by dx at 0.9 and we want dy by dx at 1.1. So we want dy by dx to the left and to the right. Now, here we have to find some space. But anyway, let's use this space up here. Dy by dx at 0.9. 2 times 0.9 minus 2 is what? 2 by 0.9 is 1.8. 1.8 minus 2. What is 1.8? So we have 1.8 minus 2 is going to be a negative. Once you know it's a negative, you're okay. You don't necessarily have to be finding out exactly what the value is. Once you know it's a negative, you're okay. But let's still use the value. It's negative 0.2. Alright. So dy by dx is a negative. Now, at 1.1, what happened? When x is 1.1, what you have is, well, it's 2 times 1.1. So we're substituting here for the dy by dx. 2 by 1.1 minus 2. 2 by 1.1 is what? It's 2.2 minus 2 equal what? 2.2 minus 2 is positive 0.2. So we know that to the right it is a positive value. Alright. Now what that means is that if you should locate the stationary point, this dy by dx is 0, so you have a horizontal line, right? It's going to be a horizontal line. The tangent touched the curve. My tangent seemed to cut the curve a bit, but it's a horizontal line. You then have to the left a negative gradient, mean the tangent would run from upper left to lower right. And to the right is a positive gradient, meaning the tangent would run from lower left to upper right. In fact, let me use different colors for these tangent. To the left you have a negative gradient, and to the right you have a positive gradient. What this means is that going from left to right, you're going down, then flat, and then up. Meaning that it is a minimum point. So that also shows you that we have a minimum point here. You see that? It's a minimum point. Alright. Don't want to crowd this thing, the graph, too much. So we have a minimum point here. So that's a second method to find out what kind of stationary point it is. The nature of a stationary point in this case is minimum. Now, is there yet another way to find out the nature of the stationary point? Let's see in another video. So I will see you in the next video.